Chapter 3: Measuring, Cutting, and Joining Pipes. 1. Cast iron pipe. For so many years, cast iron pipes has been used for all types of plumbing installations. It was proven good and durable material for house sewer, house drain, soil, waste, and vent pipe on various type of building. The use of cast iron pipes, however, was limited by the code to less than 25-story high building where constant vibration is present. Vibrations loosen the lead caulk joint between the pipes, causing unwanted sag and water leak. Cast iron pipe is affected to some extent by corrosion due to chemical action in the system that is impossible to control. The commercial length of cast iron pipe is 150 cm long, with various diameter ranging from 50 to 150 mm, with the following types: standard pipe, single hub, double hub, and hubless pipe. Cost is always associated with the kind of pipe to be used. Thus, it is important to know the specific use of each type. Recommended uses. 1. The standard pipe is used for a well-fitted hub and spigot connections. 2. The single hub is recommended when the length of a pipe needed is more than 150 cm long, wherein cutting is not necessary. 3. The double hub is preferred when the piece of pipe needed is shorter than 150 cm long. When the pipe is cut, both end has hub to serve as joint connector. 4. The hubless pipe is used in lieu of a single hub to do away with the caulking of joints. It is cheaper and easily connected using a neoprene rubber sleeve. Figure 3-2 shows the joining hubless cast iron pipe. Table 3-1 shows the weight of soil pipe up to 150 cm long. Table 3-2 shows the effective length of cast iron pipe. Figure 3-3 shows the laying length of cast iron pipe. 2. Measuring length of cast iron pipe. In measuring length of cast iron pipe, the end portion that will enter into the hub is added to the face length of the effective distance. Figure 3-4 shows the face-to-face length. Table 3-3 shows the additional length in cutting cast iron pipe. The additional length is for one end connection only. If both ends are inserted into the hub, the length should be doubled. Illustration 3-1. From figure 3-5, find the length of the cast iron pipe required to connect the installation and determine what type of pipe should be recommended and why. Please refer to figure 3-5 from the book. Solution. 1. The length of the face distance is 120 cm. Refer to table 3-3. The additional length for a 50 mm or 2 inches pipe is 6.2 cm. Now, add 120 plus 6.2 equals 126.2 cm. 2. This is the length of the pipe required to connect the installation. As to the type, double the hub is appropriate because the length required is less than 150 cm. The excess pipe with hub after cutting could be used on other joint requiring hub. Illustration 3-2. From figure 3 to 6, find the number and length of the cast iron pipe required using 100 mm or 4 inches diameter. Solution. 1. The face-to-face distance is 360 centimeters. From table 3 to 3, the additional engagement length of a 100 mm or 4 inches pipe is 7.5 cm. Thus, the two-end engagement length is 7.5 plus 7.5 equals 15 centimeters. 2. The total length required is 360 plus 15 is equals to 375 centimeters. 3. Divide the total length by the effective length of one pipe. 375 divided by 142 is equals to 2.62 pipes. 4. The whole number 2 means 2 pipe at 150 cm long. The amount of 62 means the fraction part to be cut or taken from one pipe. In short, this is less than one pipe length. 5. Therefore, the pipes required are 2 pieces 100 mm at 150 equals to 3 meters. 1 piece 100 mm at 99 cm equals to 93. The total length is 3.93 meters. Illustrations 3 to 3. The installation as shown on figure 3 to 7 specify the use of 75 mm diameter hubless pipe. Find the number of pipe and the neoprene rubber sleeve, including the accessories required. Solution. 1. The installation distance is 6.5 meters. Refer to table 3 to 2. The effective length of a 75 mm hubless pipe is 150 meters. Divide by the effective length. 6.5 meters divided by 1.5 is equals to 4.33. 2. The installation therefore requires 4 hubless pipes and length of one pipe is 49.5 cm long. 3. The total number of pipe required will be 4 pieces 75 mm 150 cm hubless pipe and 1 piece 75 mm by 49.5 cm long. 4. By direct counting, the neoprene rubber sleeve and other accessories are 5 pieces neoprene rubber sleeve, 5 pieces stainless steel shield, 10 pieces screw clamp. 3. Cutting and connecting pipes. The procedures in cutting cast iron pipes are as follows. 1. The chalk mark is drawn around the pipe. 2. The pipe is laid on sand. 3. With the use of a hammer, a cold chisel, the scored line around the pipe is struck gently at first round. Then continue striking harder and harder all around until the pipe is cut or part of it. Figure 3 to 8 shows the cutting of cast iron pipe. Table 3 to 4 shows the quantity of oakum and pipe joints. Caulking joints. Caulking joints of cast iron pipe is done through the following steps. 1. Make sure that the pipe to be joined are perfectly aligned with the spigot centered inside the bell. 2. Wrap the oakum around the spigot neck, filling the space around the inner hub. With the use of a yarning iron, drive the oakum into the bottom of the hub. Then compress firmly to make a solid bed, providing 20 to 25 mm clearance from the top of the bell. 3. After packing, the joint is sealed with the lead monolithically poured around the inner hub at about 3 mm above the bell, then packed against the hub by the caulking iron tamping it firmly to make a watertight seal. Figure 3 to 9 shows the caulking CI pipe joints. Table 3 to 5 shows the quantity of lead per pipe joints. Illustration 3 to 4. Determine the quantity of oakum and lead in kilograms required for a drainage installation with the following joints. 8 joints of 50 mm pipe, 14 joints of 100 mm pipe having 20 mm lead packing. Solution 1. Refer to Table 3 to 4 and Table 3 to 5, then multiply. Oakum 8 joints times 0.05 is equals to 40 kilograms. 14 joints times 0.15 is equals to 2.10 kilograms. Lead 8 joints times 0.50 is equals to 4 kilograms. 14 joints times 1 is equals to 14 kilograms. 2. Order 2.5 kilograms oakum and 18 kilograms pegged lead. 4. Galvanized steel pipe. Working with galvanized steel pipe is somewhat difficult because of its rigidity and the threading process involved, plus the joining operations. The face-to-face method is applied conveniently in measuring the length for a connection. However, allowance for the thread that will enter into the fitting should be provided. Working with galvanized steel pipe involved the following considerations. 1. Direct connection. 2. Measuring and cutting. 3. Threading operation. 4. Sizing of the pipe. Direct connection refers to the manners of planning, the layer, and rerouting of the pipe to reach the point of service. All pipelines should be installed as short and direct as possible. The number of fittings and pipe cuttings plus the threading work can be reduced to the minimum required if the plumbing layout was planned carefully. Measuring and cutting. Errors committed in the measuring and cutting of pipe may mean additional pipe and fitting, cost of labor, and the risk of water leakage. The face-to-face method of measuring and cutting of pipe connections is considered the most reliable. The procedures were already explained in connecting cast iron pipe. Cutting and threading operations. On cutting and threading operations, steel pipe should be held rigidly with the proper holding tools. Cutting is done by using a 14 teeth per inch hacksaw blade, applying forward stroke at the rate of about 1 stroke per second. Remember that fast cutting will overheat and break the blade. After cutting, the burrs are removed from the inside edge of the pipe with files or reamers. Threading of steel pipe entails a very tedious process. Hence, it is important for one to know beforehand the basic rule governing the threading operations enumerated as follows. 1. Never hold threaded part with a wrench. It will surely damage the thread. 2. Put 2 nuts on them, lock tightly, and continue the threading operations. 3. During the process of threading, apply motor oil regularly to protect both the threader and the thread of the pipe. 4. To ensure tight and rigid connections, the threads should be slightly tapered so that the turning of the fitting will be harder the deeper you screw. 5. Provide the threaded portion of the pipe with a Teflon tape in a clockwise direction before turning the fitting joint to obtain a water-sealed connection. 6. The use of ready-made nipples ranging from 2 inches to 12 inches long was proven economical than fabricating them on site. The amount of cutting and threading as well as the time of installing is reduced substantially. Table 3 to 6 shows the length of the screwed pipe into the fitting. Not all the threads are screwed into the fitting by forcing through may result in splitting of the pipe fittings. Illustrations 3 to 5. From figure 3 to 10, determine the length of galvanized steel pipe required to connect the installation using 12 mm or 1/2 inch pipe. Solution. 1. The face-to-face distance is 4.3 meters. Refer to table 3 to 6. The additional length of the screw inside the fitting for a 12 mm pipe is 1.2 centimeters. 1.2 centimeters times 2 ends is equals to 2.4 centimeters. 2. Add to the face-to-face clear distance. 430 centimeter plus 2.4 is equals to 432.4 centimeters. Table 3 to 7 shows the pipe diameter equivalent in millimeter. Determining the GI pipe diameter. The size of galvanized iron pipe is the diameter of its hole, not the outside diameter. In the absence of a measuring caliper, the inside diameter of a pipe can be known by measuring the outside circumference of the pipe with a string. With the aid of table 3 to 7, the inside diameter could be found easily. Table 3 to 8 shows the wall clearance for pipe installations. Table 3 to 9 shows the length of a Teflon tape on pipe joints in meter. Illustration 3 to 6. Determine the amount of Teflon tape required for the following number of pipes and fittings connections specifying 5 rounds per joints. 12 millimeters have 16 joints. 20 millimeters have 12 joints. 25 millimeter have 10 joints. Solution. 1. Summarize the joints according to the pipe size. Refer to table 3 to 9. Then multiply. 12 mm that has 16 joints times 0.335 is equals to 5.35. 20 millimeters that have 12 joints times 0.415 is equals to 4.98. 25 millimeter that have 10 joints times 0.565 is equals to 5.65. Total length of Teflon tape is equals to 15.98 meters. 2. One roll of Teflon tape is 1 meters long. Order 16 rolls. Copper pipe. Copper pipe is classified into 2 types. 1. The rigid type. 2. The flexible type. Copper pipe working procedures. 1. In measuring length of a rigid or flexible copper pipe, the face-to-face method is also applied. The depth of the soldering hub is added to the clear face-to-face length of the pipe. 2. Cutting of copper pipe with a suitable rotary tube cutter will give the best and satisfying result. In the absence of a rotary tube cutter, the hacksaw blade with 24 teeth per inch is used on heavy pipes and the 32 teeth per inch for the thinner one. 3. Cutting is done through a gentle light forward stroke. After cutting, the burrs are removed inside the pipe with a file or reamer. Figure 3 to 10 shows the drawbar bending machine with pivoted mandrel. 4. Copper pipe are bent slowly on a wide radius to avoid kinking. Bending a pipe is easily done with a pipe bending machine to produce a very satisfactory result. Another way of bending copper pipe is by using a steel spring inserted inside the pipe to produce a smooth, clean curve. Soldering copper pipe joints. 1. Clean thoroughly both ends of the pipe to a bright finish including the inside of the fitting with emery cloth or fine sandpaper. 2. Apply a thin coat of non-corrosive flux or soldering paste to all clean surface of the pipe and fittings. 3. Place the fittings up to the hub and rotate for several times until the flux is evenly spread. 4. Wipe the excess flux around the fitting and solder in one operation only. With a propane torch, heat the fitting uniformly around the pipe. 5. Never allow the flux joint to stand for more than 3 hours before soldering. 6. During the process of cooling, avoid disturbing the pipe or the fitting, for it might weaken or break the seal. Figure 3 to 12 shows the soldering copper pipe. 7. Avoid soldering the pipe that contains water. Wrap other connections with wet rags in the same fitting before soldering to avoid melting of the finished joint. Table 3 to 10 shows the copper pipes technical data. Figure 3 to 13 shows the joining of copper pipes. First, clean pipe with emery cloth. Apply flux. Lastly, rotate to spread flux. 6. Plastic pipe. Plastic pipe is a new concept in plumbing for all types of building. Plastic pipe has been accepted worldwide after it has in many ways proven itself to be superior as sour and cold water pipeline material. The simplest way of joining plastic pipe is by cementing called solvent welding. Solvent welding takes only about 1/4 the time it takes to assemble bell and spigot joints. Working with plastic pipes. 1. Measure the face-to-face distance of the fitting to be connected. Add the engagement length before cutting the pipe. Figure 3 to 14 shows the face-to-face distance and engagement length of plastic pipe. 2. Some plastic pipe can be cut with a sharp knife, but all can be cut with hacksaw or handsaw. A rotary pipe cutter should not in any manner be used in cutting plastic pipes. 3. Be sure to cut pipe ends square or at right angle with the axis of the pipe. Work on one joint at a time. Solvent is very quick setting and unforgiving of mistake. Once an error is committed, the only remedy is to cut the pipe and have it replaced. 4. After cutting, Remove the burrs inside the pipe. Rem and clean the end portion of the pipe until smooth to allow full contact with the fitting shoulder. Clean the pipe end with methyl ethyl ketone or MAK or simply acetone. However, depending upon the type of plastic being used, there are solvent that needs no cleaning of the pipe before its application. 5. Apply solvent cement liberally using non-synthetic brush to the shoulder fitting and butt ends of the pipe. 6. Insert the pipe into the fitting and give it a quarter turn or 1/4 turn. The span of time from the cement application to the quarter turning should not be more than 30 seconds. 7. Do not disturb the pipe for several minutes after the quarter turn. Wait for about 2 hours before testing the line under pressure. Drying of the cement must be far enough advanced, from 15 to 20 hours, to permit use of line. Figure 3 to 15 shows the repairing damaged plastic pipe using coupling. 8. In the process of bending, plastic pipe is packed with the sand, then heated using a flame torch or hot water. Apply pressure gently and gradually when the pipe is soft and ready for bending. Continue bending until the desired curvature of the pipe is arrived at. A metal spring for bending copper tube may be used to prevent flattening of the pipe. 9. Correction or repair of lines may be done by cutting the pipe at a reasonable distance away from the side of the fitting, then connect with coupling or socket. See Figure 3 to 15. Table 3 to 11 shows the engagement length of a 3-meter pipe. Table 3 to 12 shows the engagement length of a 6-meter pipe. Table 3 to 13 shows the quantity of solvent cement per joints. Illustration 3 to 7. List down the material required to install the drainage pipe using 63 mm by 3 meters plastic pipe and 100 mm by 6 meter pipe as shown in Figure 3 to 17. Solution 1. Using 3-meter plastic pipe. 1. The face-to-face distance is 44.4 meters. Divide by the length of one pipe, 3 meters long. 44.4 meter divided by 3 meter is equals to 14.8 pieces. 2. This simply means we need 14 pipe at 3 meters long and 0.8 of one pipe. Multiply 3 times 0.8 equals to 2.4 meters. 3. From table 3 to 12, the engagement length at 2 ends is 2 times 7.5 centimeter is equals to 15 centimeter. 4. Add the result of 2 and 3. 2.4 plus 0.15 is equals to 2.55 meters. 5. Order. 14 pieces, 62 mm by 3 meters. 1 cut at 2.55 meters. 13 pieces, 63 mm coupling joints. 6. Solve for the solvent cement. There are 28 joints. See Table 3 to 12. For 63 mm pipe, multiply 28 joints times 5 is equals to 140 grams. Solution 2. Using a 100 mm by 6 meter pipe. 1. The face-to-face distance is 44.4 meter. Divide by the effective length of one pipe. Refer to table 3 to 13. 44.4 meter divided by 5.87 is equals to 7.56 pipe. 2. This simply means we need 7 pipe at 6 meters long and 0.56 by 6 meter pipe is equals to 3.36 meter. 3. Find the engagement length at the two ends. Refer to table 3 to 12 along 100 mm pipe size. Multiply 2 times 14 is equals to 28 cm or 0.28 meters. 4. Add step 2 and 3. 3.36 plus 0.28 is equals to 3.64 meters. 5. Order 7 pieces 100 mm by 6 meters pipe and 1 cut at 3.64 meter long. Illustrations 3 to 8. As shown in figure 3 to 18, a water supply line is to be installed using a 6 meters long plastic pipe with a diameter of 160 mm. List down the material required. Solution. 1. The face-to-face distance is 28.5 meter. 2. The effective length of one 6 meter pipe is equals to the laying length minus the telescopic length. See table 3 to 12. 6 meters minus 0.16 meter is equals to 5.84 meters. 3. Divide the face-to-face distance by the effective length of one pipe. 28.5 divided by 5.8 is equals to 4.88 pipes. 4. This simply means we need 4 pipe at 6 meter long plus 0.88 of one 6 meter pipe. 0.88 times 6 meters is equals to 5.28 meters. 5. Solve for the additional engagement length at the two ends. 16 times 2 is equals to 32 centimeters or 0.32 meters. 6. Add step 4 and 5. 5.28 plus 0.32 is equals to 5.6 meters. 7. Therefore, the materials required are 4 pieces 160 mm by 6 meter plastic pipe single hub and 1 piece 160 mm pipe cut to 5.6 meter hubless pipe. Figure 3 to 19 shows the various plumbing tools. Pipe cutter, monkey wrench, basin wrench, strap wrench, chain wrench, Stilson wrench, pipe wrench, threader, yoke vise. Determining a distance with offset angle. It is sometimes necessary to offset a run of pipe around the light fixture, a post, or other obstruction. An offset can be made using 90 degrees or 45 degrees elbows. The 45 degree is better because there is less friction and therefore less pressure drop when 45 degree fitting are used. Likewise, it is very easily to calculate the length of the pipe needed for 45 degree offset. Table 3 to 14 shows the ratio of offset measurement. Illustration 3 to 9. Find the travel distance of the pipe if the offset angle is 45 degree and the offset length is 30 cm. Solution. 1. Solve for the travel length. Referring to table 3 to 14, along 45 degree offset angle under column ratio of travel to offset, the value is 1.414. Now multiply. Travel length equals 30 times 1.414 is equals to 42.42 centimeters. Other plumbing tools are propane torch, yarning and caulking iron, blowtorch, melting pot and ladle.